everybody. I'm very excited for this talk since Kubernetes for me is also a brand new technology. And all this started like 1 to 2 months ago, where we looked into Kubernetes, researched, get an idea what it is, how people do monitor it at the moment, what they do, what challenges they are facing, how Kubernetes works, and how Icinga could monitor Kubernetes. And I think Daniel's talk was a great introduction to one of the powers of Kubernetes, so where you saw when a pod gets deleted, then it gets automatically recreated and all that stuff. And Kubernetes also has like nice scaling. If you need more instances, then it just scales up. And if you need less instances or have less usage on your cluster, then it scales down. So it's a pretty cool tool, but also Daniel's talk somehow has hidden the fact that you need a running Kubernetes cluster for that. So, and in order to have a running Kubernetes cluster, of course, you need monitoring to see when it fails. Yeah, my name is Eric. I'm with Icinga since the beginning. Before looking into Kubernetes, I've been doing IcingaDB in Lightspeed, as you know. And now, yeah, I think for the next weeks and months, I will be focusing on the Kubernetes monitoring. But before we go into that, I want to leave some words about good old traditional monitoring, where Icinga shines. So there we have, of course, we have our hosts, right? Those is all rather static. I mean, we deploy them. If they fail, we can still SSH into them and look for errors. Basically, normally you have the availability checks for them. Then on those hosts, you have your services like resource usage, CPU, memory, disk, and whatnot. And of course, you monitor apps like web servers, databases, URLs, whatever. And all that is done by check plugins. We had a talk before about the great check plugins from the Linux fabric. So now we actually have some good check plugins. And those check plugins contain the logic, right? So it contains the logic for how to gather data, how to analyze the data. They have thresholds, and they evaluate, okay, if it reaches a certain threshold, we have a warning or a critical. And that is good, or that is cool, because not each and everyone implementing like checks has to think about all those thresholds and the logic analyzing it. So you just use the check plugin, and if it goes wrong, you get your alert. And that's pretty cool. So you don't have to set up your own rules. Of course, with traditional monitoring, we also have some automation. We have configuration management. We saw that earlier. We have our director with the various import sources where we can get configuration in from various tools, whatever. And then we have Icinga APIs where you can also push new objects in. And metrics, I mean, you have them rather automatically by performance data of check plugins. But usually you only use them maybe for analyzing the history of stuff, but not really checking based on metrics. I mean, of course, you can check based on metrics. For example, if the disk is rising another 30 minutes in that rate, then I get a critical. But normally, all the stuff you do is via check plugins. So now all that changes, I would say, when it comes to monitoring Kubernetes, because this one is a whole nother beast. Who's using Kubernetes? Cool, some. Who knows, apart from you guys, how it works? Okay, 1 or 2 more. Okay, so I just go over it really, really quickly. Kubernetes has some components, etcd, single source of truth where everything's in, API server, scheduler, controller manager, kubelet, and whatnot. And on all this stuff runs on nodes. And you have, of course, a container runtime where containers run in. So, again, we have containers. And on, let's say, worker nodes, you also have some parts of Kubernetes where you schedule your workload items like your applications, Redis, Consul, GitLab, whatever. And yeah, I mean, the problem maybe is if people also try to use Kubernetes even if they don't have the application for it, because it's so hip and you don't have to miss the hype train, right? So you put like everything in, but yeah, it's pretty complex beast. So when it comes to monitoring Kubernetes, you have to ask yourself what to monitor. I just want to say I'm not a Kubernetes expert by no means. I mean, I started like 2 months ago, but that is what my research gave me. So what should we monitor? And there's, of course, the hosts where Kubernetes components run. That includes also the Kubernetes components itself, so like the etcd scheduler and all that stuff. Then you monitor the workloads, so your actual services on Kubernetes, for example, deployments, daemon sets, stateful sets, cron jobs, whatever. And those, let's say, items create pods, and in those pods run at least one container. There can be more. And you also want to monitor that, of course. And you want to monitor key metrics. Kubernetes itself provides a lot of metrics, and you want to pick the right ones in order to see what actually fails. So it's not only the infrastructure you're monitoring, so infrastructure-wise you have the Kubernetes nodes where stuff is running, but you also have the workloads to monitor, so the stuff you put into Kubernetes. And there you get let's say, a lot of complexity, since Kubernetes provides a load of resource types. I don't know, I think it's 70. Not all of them are workload resource types. They're also configuration resource types, config maps, security stuff, roles. Kubernetes is built in multiple components across multiple layers. And because of that, you have different failure points, right? So a container could be wrong, a pod could be wrong, then your service could be wrong, so the daemon set, deployment, whatever. There could be something in the node or in the Kubernetes component itself. So basically, you have to understand the whole Kubernetes stack in order to interpret metrics and also interpret errors and events Kubernetes emits for you. And yeah, now you might ask, all those stuff via host services and check plugins? Yeah, it's not so trivial, since all that stuff is so dynamic that the classic, let's say, host and service configuration, yeah, is not appropriate. Also, we already heard that the core concept is that everything is ephemeral. So that means that you run it, and if you destroy it by a failure or a restart or whatever, then it gets respawned, and all the stuff you had is lost if you didn't configure a persistent volume or stuff like that. So you lose logs, metrics, events, and all that stuff. Also, you have the challenge that pods come and go. So pods are those workload or deployable units in Kubernetes where containers run. They can also come and go and change their names because you scale your infrastructure up or you scale your infrastructure down. You have cron jobs, spawning jobs, and if they're successful, then the pod gets deleted. So you have to monitor not the pod, but the cron job. And that means that you have to collect everything, but for alerting, you don't usually alert on the container level or on the pod level, but on the application level, which spawns all that stuff. And then you have metrics. So Kubernetes provides a lot of metrics out of the box, and then you have Prometheus and some Prometheus components which expose metrics, and there are a lot of them. And the problem is that you have to understand them in order to use them. And also, now imagine maybe an Icinga with check plugins, but without check plugin logic. So the check plugin would only collect metrics, but do nothing else. That would be really useless, Icinga-wise, right? But that is the situation somehow with Kubernetes. So we have a lot of metrics, but you don't have check plugins with logic, which combines and evaluates that in order to provide you alerts. And that's why it's so different to traditional monitoring. So to break that down a little bit even more, so the multiple layers in Kubernetes, what we have the cluster, and of course you can have more than one Kubernetes cluster. And a cluster is built on nodes. On a cluster level, maybe you want to monitor the resource usage. So for example, is my cluster overutilized or underutilized? Do my Kubernetes components run well? On the node level, you want to monitor whether the number of nodes are sufficient to handle the workload. Also, you may want to account node failures, so that if one node goes down, is it possible that all my other nodes can handle all the workload I have just deployed? And also, you want to maybe monitor the capacity of pods, so you can only spawn a certain amount of pods per node. Also, per node, you have IP addresses, which can be, which the pods get. So you also want to monitor IP capacity. And of course, you also want to monitor node usage, so CPU, memory, storage, traffic, latencies. But that is basically for every layer of Kubernetes, you want to monitor all those resources. Then for pods, you want to monitor resource usage against requests and limits. So you can configure that pods only consume a certain, let's say, amount of CPU and memory, and you want to compare that to their actual utilization. So is the pod using actually all of that, or is he using less than that? And container-wise, yeah, you basically only have logs, but there's also resource stuff. And in the end, all that is, I mean, you want to know the health of the Kubernetes components and workloads you have. And the health you get from events, which Kubernetes emits for you, metrics, which you have to understand, resource usage, which you have to evaluate, and of course your expectations. So you say, for example, that you want to have like 5 instances of your application running, and then you can monitor, is that actually the case, or are there only 3 instances instead of 5, and all that stuff. So Kubernetes provides already something which is called probes, so you can configure that on a container level. You have let's start on the bottom, you have a startup probe, which says, okay, if that probe, this can be a check command or I don't know, TCP stuff or a HTTP call, whatever, or just a binary which is executed. So if the startup probe fails, Kubernetes will automatically restart the container. But if the startup probe succeeds, then it will move on to the readiness probe. And the readiness probe will then tell Kubernetes to move that container in that pod to a certain service which is assigned. For example, we had Icinga web with a service in Daniel's talk, and Kubernetes, you need, of course, an object which tells that something is available to the outside. And if that container, Icinga web, wouldn't have passed its readiness probe, then it wouldn't be available to the service which exposes Icinga web in Kubernetes. So when the readiness probes is okay, then you have a liveness probe, which is periodically checked by Kubernetes as well, and also at container start. This is also HTTP call or a, I don't know, TCP or binary, whatever, and it checks container liveness. So you can basically define anything, and if the script passes, Kubernetes says everything is okay, and if it doesn't pass, then Kubernetes will restart that pod for you automatically. So, okay, now we have all those stuff. So maybe we know what to monitor, it's a lot, right? So how could we get all those information? One possibility would be to pull the various Kubernetes APIs to get all that stuff. We could install an agent automatically on every node via daemon sets, and that agent would have the logic to gather events, logs, metrics, whatever. We could have an agent per pod via a sidecar container also for collecting stuff. But you could also gather events, metrics, and logs from Kubernetes itself. And of course, there's also a whole other topic, application performance monitoring, which you could also bring into the field. And maybe, yeah, it makes sense to combine all of those. And there are several monitoring tools which, for example, use the daemon set approach, where they publish or install automatically their monitoring agents on all their Kubernetes cluster nodes. And yeah, later on I'll show you how we maybe will do it. So yeah, to put it right, I mean, metrics in Kubernetes is the thing. So without metrics, you can't do anything. And I mean, compared to check plugins in a traditional monitoring, we already monitor metrics, for example, the CPU usage, zombie processes, disk, whatever, but it's not just a simple metric, but with logic. Here in Kubernetes, we only have the metric. And we have to have a look at many metrics, and we have to get them. So one famous thing is the Prometheus node exporter, which runs on every node, which exposes node metrics like pod usage, resource usage, all that stuff. Then you also have container metrics by CAdvisor, which is already built into kubelets, so that you already get for free. And then there are various Kubernetes metrics which are exposed from Kubernetes itself. And there's also the project kube state metrics from Kubernetes, which also provides, let's say, Kubernetes cluster-wide metrics about how many pods there are, how many are expected to be run, how many are failing, and all that stuff. So there's a lot going on metrics-wise. Now, Icinga Kubernetes monitoring. I mean, we got the question, over the last 1 or 2 years, a few times. How could Icinga monitor Kubernetes, or how is Icinga supposed to monitor Kubernetes? And we didn't have an answer since we didn't know Kubernetes. And maybe it was also good since, I mean, now Kubernetes is rather mature, and there were a lot of tools and a lot of components which are now deprecated. And now maybe the foundation is good enough so that we don't have to develop stuff all over and over again because Kubernetes components are deprecated. What we are doing, or what we want to do, is that we want to collect all the Kubernetes resources and all the stuff Kubernetes itself emits for them. So Kubernetes users know the commands kubectl logs, kubectl get pods, kubectl describe, whatever, and all this stuff is, I mean, this is data from Kubernetes itself. And this includes health information which is provided, events, metrics, and container logs. And not only do we want to collect them, we want to, of course, also visualize them in a web interface, and also maybe to reduce complexity for somebody who's not so hard into Kubernetes that he sees over drill down, going into detailed areas, how all those resources are tied together. And that is what we have at the moment. I show this later. But of course, the Kubernetes monitoring should also correlate all that stuff. So for example, in Kubernetes, events are also something that disappear over time. So you don't see all events all the time. But for example, if a container is crashing, not constantly, but I don't know, once or twice a week, then you don't see that in the events for the history. You only see the last week, for example. But if you would store that events into like event storage, you could have a look what happens over time. So is a container crashing often over time, for example? Of course, we want to provide alerts. So there's no good monitoring without alerting, right? The downside is that we don't have check plugins, which does the heavy lifting for us, so we have to do this on our own. The idea is to use Icinga notifications of that, of course. So this is a complete different configuration and software architecture compared to what we have right now. So there won't be any host or service configurations in Icinga 2 directly. It's basically only using Icinga Web for integrating into our views, but core-wise, it's something completely different. And the monitoring could also give configuration tips. There's a lot of stuff you can do wrong in Kubernetes. For example, you could open node ports for no reason. You could have maybe no load balancer where it should make sense. You could have too much load balancers instead of a shared one. There's cool stuff called affinities and anti-affinities. For example, if you say my application has to run at least three times, then Kubernetes may deploy those 3 instances to the same node if it has enough resources. And now if that whole node goes down, all your 3 instances of your application goes down, so that is not very clever. But with anti-affinities, you could say, okay, don't schedule all of my instances on the very same node, so Kubernetes distributes that for you automatically. But you have to configure that, of course, so Kubernetes is not doing this for you. But we could, have like analyze We could analyze the configuration and look for certain points which are common now or are common since there are many people making mistakes with Kubernetes and there are so much resources about failure stories. We can build all that knowledge into like some configuration and correlation checks and give tips and alerts on the same time for that. So what do we have? How does it look? We have a daemon written in Go, of course. Why in Go? Because that makes perfect sense and it's a perfect fit for Kubernetes since Kubernetes is written in Go. And we're using the Go, let's say, Kubernetes client SDK for our daemon. That's also cool since we have built-in compatibility with the new features that are evolving in Kubernetes itself. And the daemon is responsible for collecting all the resources from Kubernetes, health, events, metrics, and all that stuff. Kubernetes has the concept of list and watches. So for each and every resource, the Kubernetes API provides a list function, which lists all the resources Kubernetes at the moment knows. It lists, or it gives you the configuration, the state it has at the moment, and of course its desired state, since Kubernetes boiled down to one sentence is a controller which moves over certain iterations a current state to a desired state. And then it has watches where you basically get events of changes happening in Kubernetes. So we list all the stuff, and if we get changes to the stuff, we get that for free, all by the Go SDK. I mean, not for free, you have to do some code, but the Kubernetes client libraries are pretty good. And of course, the daemon should send alerts in the end. We are storing all of that stuff in a database, of course. I mean, you all know we love databases, and we don't have a lot of them, so we need some more. Again, this is PostgreSQL, MySQL, or MariaDB. You see in the slide here that the daemon, this is this one, they are talking to each other. No, not to each other. Icinga Kubernetes just queries it. And basically, it could run inside Kubernetes, but it also could run outside Kubernetes. So that is also, you get that basically for free from the Go SDK. It can run inside and outside. Then again, database could also be inside your Kubernetes cluster or outside, whatever. And this one is synchronizing all the resources, events, and so on into the database. And on top of that, we have the web interface, like you know that from all our other modules, which is built for Icinga Web as a module, where you manage configuration. So, for example, you don't manage configuration at the moment. I don't know. So you can view resources and hierarchies in the web module. You have like list views and detail views, and in the end, the Kubernetes web interface will give you insights into configuration, give you tips, and also notify or indicate you about problems it found. Then I have this a little bit bigger, since you could have more Kubernetes clusters, right? And still our idea is to have them all, write them into a single database, like we do that with IcingaDB. So IcingaDB is also, you could have multiple Icinga 2 different instances writing into the same database, so that you only have one web interface which can display all information about all your clusters. And of course, there's some more ideas. I mean, we could, for example, like I think I mentioned it in the beginning, we could account for node failures, meaning that if we detect that the current usage is too high, if a node fails, we could give you an alarm. We could, for that, indicate overcommitment of nodes if we compare the configured requests and limits to the actual usage. DNS is also a thing in Kubernetes, of course, so we have to monitor that. We could also monitor the Kubernetes probes, so how often they fail, for example. One cool thing we could do is monitor latencies, of course. For example, how long does it take to schedule new pods, and if this takes longer than like the last 2 weeks, then there may also be a problem. You can monitor traffic, and also, like I said, the affinities and anti-affinity stuff. And there's lots of stuff more. And now I want to show what we have right now. Okay, I have a really big Minikube cluster. Since I'm a hardcore Kubernetes user, I don't have any app. I just deployed some stuff from somewhere. So basically, wait a moment. Maybe that. Okay. So I go to replica sets because there we have some failing stuff. So the idea is, like with every other module, we have like list views, which give you an overview of the stuff you have, and with a visual indication what is going wrong. For example, I have a gateway. This one is called gateway quota because I configured quotas, which my pods, which is impossible for some pods to be deployed since my quota says I only allow one pod. You see like right from the beginning what is expected, so what are your expectations config-wise and what is the current state Kubernetes-wise. And from there you get the drill down into the detail area of the replica set here, for example. I just do that since it's a little bit bigger. There we have events, and this is basically the same as kubectl, where you get your events, but you don't have to like execute 3, 4, 5, 6, or 7 commands in order to get there. Here we clearly see that, that I requested one pod, but my quota is limited to one pod. That's why it's failed to curate. But we have one pod running here, and we can go into that. There's one container running on it. I can click on that one. Also see the details there. See various Kubernetes conditions. All of that is provided by Kubernetes, so there's no monitoring component actually doing stuff right now. This is just scraping the Kubernetes API and doing a visualization on top of that. And then I go get in detail to the container, have a look at the logs. Okay, this one has no logs. This is boring. I have console, and I think console has logs. Look at that one. Container running. Then you see some logs. So, yeah. And also a cool thing about that we have all this stuff in the database. Kubernetes also has labels for each and every resource type. Either you define them or they're defined by a deployment you already use. So we could have like searches for labels, which then lists all resource types which are targeted by this label. Since we have everything in a database, we can correlate information much better than just doing thousands of API requests trying to gather information and combine that. Basically at the moment we have workloads. We have nodes. I only have one node. It's pretty boring. Deployments, replica sets, daemon sets. I mean, who knows Kubernetes knows that stuff. What we don't have at the moment is configuration, config maps, mounted volumes, persistent volume claims, all that stuff. So there's a lot of more work to do to only get all the resources into the database and then visualize them. And after that, we can build alerts on the health indication Kubernetes provides. So for example, this one here, app with insufficient cluster resources. This one is unhealthy, of course, because there's not a single pod running. We could provide alerts of that automatically. Also considering that Kubernetes takes some time since it has like auto-healing, we saw that. So we can't just send a notification or an alert like right away, but wait a little bit since Kubernetes might heal itself. But if it doesn't, you want to have an alert. And after that, we can get metrics into play, build some rules around that one, all with the traditional monitoring approach in mind that you have check plugins where the logic is built in. So I think at the moment, the only thing you do is like you have Prometheus with loads of metrics. And then you have maybe some alerts pre-configured, maybe not. And if something goes wrong, then you configure your rule or your alert via the alert manager. But traditional monitoring approach is like you have that beforehand, right? So you have a check plugin which does the stuff. And I think this can be combined somehow with the Kubernetes stuff and the Kubernetes failures and all the publications about Kubernetes and how it could go wrong, that we could use that information to build checks around that and integrate that into the Icinga Kubernetes monitoring. And that's, sorry, basically it. Thank you.
Thank you very much, Eric, for sharing the insights. Hands were raised so fast I couldn't even catch up. So we go straight into questions.
Yeah, Eric, thanks for the new integration. I have two questions. The first thing that came to my mind when you talked about the database is I don't see something like Redis there, and we have very volatile state changes. What makes you sure you don't build a second IDO?
Well, we're using a lot of the Icinga DB code we've written, so we're using also multiple connections to the database and bulk inserts. Of course, I have a very limited cluster here, right? And I load tested it with a little bit more, which my machine could do. This was not a problem. I mean, this is like a very early stage. If I wouldn't try to put Redis in, I would have nothing to show, and that would be a little bit lame. So it could be that we have like volatile state in somewhere else, and configuration state and desired state maybe in a database. Yeah, but it's not yet planned.
Yeah, another question. So the Prometheus data is there. Do you plan to scrap it like a free add-on? Like it's already there, you just take it because it's already provided?
Yeah. So the idea is not to build a metrics backend and store all metrics, because there are so many other tools which do that. The idea is to gather metrics we identified that they make sense for monitoring, and store them for a limited amount of time, so not for years, since you already saw that, I mean, pods come and go, so metrics come and go, so it doesn't make sense to keep all of that stuff. So we can also have them like aggregated on 5 minute, 10 minute, 1 day, whatever, I don't know. But I think we want to not have a look at the history so much, but rather on what they are currently, so which value they have currently. So there's not much we have to put into the database for that. So, yeah, but we will not build our own metrics exporters. We will use stuff which is already there. And if you enable metrics server, for example, in Kubernetes, then you have like a lot of stuff already, CPU, memory, storage. I mean, there's traffic missing, but you get a lot of stuff for free, and that's pretty cool. Also, what I totally forgot, so there's nothing on GitHub for that public right now. It's a private repository. And the code is rather ugly, so I won't open it right now, maybe next month.
Okay, I think we are looking forward to that. Yeah. Do we have any more questions for Eric? All right, thank you very much.
Thank you.